So let's define our variables. Let's say r is the radius of the base of the constructed cone. This is r right here. And h is the height of the cone. And the slant height of the cone is same as the radius of the sector. It's really not that difficult to see, but you want to make that connection. If this is 10, the slant height of the cone becomes 10. And this is clearly h, and we're defining the radius as r. Our primary equation is v equal to pi r square h over 3. We're trying to find the maximum volume of the cone, and the volume of the cone is pi r square h over 3. Let's take a look at our constraint. Using the Pythagorean theorem, I can conclude that r square is equal to 10 square minus h square. Take a closer look. This right triangle is being used to draw this conclusion. The hypotenuse is 10, so hypotenuse square minus h square has to equal r square. And we're going to leave the constraint in this form. R square is equal to 10 square minus h square. That's going to be convenient. So we're going to start with our constraint. R square is equal to 10 square minus h square. And our primary equation is v equal to pi r square h divided by 3. And I'm going to substitute or replace r square with 10 square minus h square. That's what I did right over here. And with a little bit of algebra, I get this right here. Now I need to find the derivative of v with regard to h, and that gives me this. Now we're going to set up v prime is equal to 0. That would imply pi over 3 times 100 minus 3h squared is equal to 0. And the algebra is not that difficult. We're going to solve for h, and if you do it correctly, you're going to get h is equal to plus minus 10 divided by square root of 3. Since h cannot be negative, we will select the positive value of h, which is 10 over square root of 3, and that's our answer. We're going to verify it, of course, but approximately h is equal to 5.7735. Using the first derivative test, the second derivative test, or an appropriate graph, we can show that the function v of h reaches a maximum value at h is equal to 10 over square root of 3. Now, I think you should do it using calculus and not just look at the graph, but I prefer graph because to me it's very visual and very convincing. If I make a mistake, I can catch my mistake better. But you also want to know how to do it using the first derivative test and the second derivative test. That's an absolute must. But I'm going to do it visually or graphically. Here, I have graphed this function, v, this is the graph, and take a look. The maximum is reached somewhere here, a little less than 6. Of course, the graph doesn't give you the right exact answer. Calculus does, and you do want to see that. The graph is a good visual tool, but the calculus tells us 10 over square root of 3 is our answer. The height of the constructed or folded cone has to be 10 over square root of 3.